So, what do you think the difference then when we talk about physics displacement? That was volume displacement, but the word really means the same. So when I talk about physics displacement, what do you think I'm getting at there? Now, what does that mean? First, well, maybe we should step back a spot there, Sam. What does physics mean in the first place?
I have no idea.
No idea? Like if someone says that they're studying physics, what are they?
I think a big
You think of the Big Bang Theory. So what do those guys do besides sit around and eat food, make fun of each other,
The same guy.
play video games, and go to Star Trek conventions?
They're like physicized stuff.
What does that mean now?
It just shows them go to work. It
Doesn't actually show what they do, right? Is what they do, what people like that do.
Like, look at the stars or something.
Yeah, but is what they do physics what I do in high school? Like if you're in grade 12 physics, are you doing the same stuff that Sheldon and Leonard are doing?
Bob's not.
No.
They're actors.
Well, that's true. I'm talking about people like Sheldon, right? Okay.
Yeah.
I don't really see what that has to do with it. Okay, so what those guys are doing, well, they're actually doing new physics, new science. What we do in high school is we're just sort of keeping about stuff that guys like Archimedes 2,000 years ago figured out, right? So it's not really new kind of thing. And what we do in high school physics is generally a lot about motion. It's not always. We talk about magnetic fields and electric fields and stuff like that as well. But a lot of it has to do with motion. That's sort of like the beginner's physics kind of thing. Okay, I'll come back to distance and displacement here. Okay, do you guys have this sheet from yesterday? I handed it out yesterday. You should. Can you find it, please? Okay, Troy, seriously. No. Gonna go right here. Really? If I see it again, I'm taking it. Okay. Okay, you need to find this sheet from yesterday, and all you're going to have to do is really follow along, fill in some blanks. Relatively easy. I made it nice and easy for you. Anybody not have one?
It's right by Michael Sharp.
Yeah, over here. Sorry. Okay, so let's talk about position. What does the word position mean?
Right there.
It means where it is, right? Where an object is. What is what position means? But there is actually more to it in a scientific sort of sense. Okay? You need what is called a reference point. A reference point. Why? These should probably be covered up, shouldn't they? Yeah. You have to fill in where an object is? Is that what you're supposed to do? I don't know what the blank one looks like. Is that what it looks like?
Yeah.
Okay. So yeah, position means where an object is. You also need what we call a reference point. Is that big enough? Do I need to make it bigger for you? Let's go a little bit bigger. There we go. Okay? So quite often we use a number line in physics to sort of help us. What would be the reference point when you use a number line? I'll give you a hint by placing my cursor.
Good. Camera.
Okay, so where do you think on a number line like that, where do you think the reference point is? Dylan, do you have this sheet from yesterday? That blank one that I gave out yesterday? Okay, where do you think the reference point is? It's right at 0. The reference point is what we call the origin, which we label as point 0. Okay? On a number line, 0 is sort of assumed, interpreted to be the origin, the reference point. And of course, to the right means positive is to the right. And of course, negative is to the left, right? And that's sort of the basic assumption that we use to sort of begin with. You guys have to draw that in there, right? Yeah. Maybe put on your sheet there, put positive to the right, negative to the left. I should get a blank one so that I know what you guys are doing. So we know that positive positions are to the right. I think you have to fill this one in, right? Right here, positive. I guess I didn't cover that one up. Positive positions are to the right of the origin, and negative positions are to the left, right? And you should probably know that probably from math class about grade 7 or 8 or so. Is that right? Roughly? It's been a while since I did grade 7 or 8 math. Certainly myself, since I was in grade 7 and 8. Okay? Technically, if you want to talk to the nerds, they will tell you that there are actually 3 parts to an object position. If someone phones you and says, "Where are you?" and you say, "I'm at Sev," well, that tells people where you are, right? But in sort of the physics sense, we have to have 3 things to tell us where an object is. And those are the origin, or where do we measure from, the distance, which is how far from the origin. Do you have this, Ryan? Do you need it? Because you need it. I was just said earlier, hey, I don't have that. You need a pencil. Pardon me? No, you got a pencil? Okay. And the last thing that you need is the direction, left or right. Now we're going to be dealing simply with what we call one-dimensional motion, left or right. Okay, we're not going to get into 2D, into projectile motion. If you take grade 12 physics, we'll take the rocket, air-powered rocket launcher, and we'll go outside and we'll launch it and we'll calculate where it's going to land and all that kind of stuff. That's two-dimensional motion. Okay? Pardon me? It is fun, but there's also some math and physics involved. So you should take grade 12 physics and then you can do it, Christian. Well, then tough luck for you. Okay, whatever. It's your choice. Okay, those are the 3 things that we're going to need for an object position. You should know those 3 things. Those are sort of one of the nice fill-in-the-blank kind of questions that appears on tests. So put a star beside that. Put a star beside it. 3 things that you need to know. Okay? Maybe you can make a cheat sheet, Christian. Then you won't have to forget. Just be right there. Okay, so let's get into what I was talking about earlier there with Archimedes and the rocks in the bathtub. Displacement. When an object moves, we say that it's changed its position. When the water moved up the graduated cylinder, it changed its position. Any change of position is called a displacement. Any change of position is called a displacement. Displacement really means how far and what direction did the object move. Okay? So if you look at this picture here with the car moves from a position of +1 to a position of +4. It was displaced. It moved. Its position moved. What is its displacement? Its displacement is going to be what? +3. Do we have it right there? Yeah, we do have it right there. Right? It's +3. What was the displacement of the water when I dropped the rocks in the water? 10. Would you say +10?
Yeah.
Would up be positive, Dylan?
Yeah.
I think so, yeah. I think we could agree to that. Right? Same idea, right? So the formula for displacement is delta D equals P2 minus P1, or triangle D. It's a triangle, Christian.
Yeah.
Do I need you to go back to kindergarten to work on your shapes?
Probably.
Yeah, I can arrange for that. I could. If you want to go back to kindergarten, I can make that arrangement. I'm sure my wife could use you in her kindergarten class as a helper, and the kids could show you the difference between a square and a triangle.
What's your wife's life?
Mrs. Bennett, oddly enough. I don't know. I think Chance was in my wife's kindergarten class. Is that right, Chance? Good times, right? All right. So, what is this triangle D thing is? Triangle D is called delta D. The triangle is the Greek letter D. The Greek alphabet, let me just show you. Well, it's going to, of course, take like 27 minutes here. Greek Alpha. I wonder if when the Greek kids eat, what's that cereal? Alphabets, yeah. Do they have like ABCs or do they have? They must eat it there, don't you think? Why not? I'm going to ask someone that goes to Greece to check their grocery store. Maybe we could go down to Mr. Cote's class and we'll make Greek alphabets and eat them for breakfast. Where's my what? Rulers. What do you need a ruler for? Triangle is, there's the Greek alphabet right there. That doesn't look like right. Oh, here it is here. Okay. So A is called alpha, B is beta, C is gamma, D, delta, right there. When you go to Greece, all the words are like with these letters. It's not like Spanish or French that uses the same alphabet. It's a different alphabet altogether. Okay, now there are some that kind of look the same. A looks the same. B kind of looks the same. E is epsilon, yeah. Theta, that you might have seen in math class before.
Yeah.
I use this letter in grade 12 physics, mu, kind of a funny looking U. The Greek letter M. Pi, you're probably familiar with that. It's the Greek letter P.
Whoa. Why can't
When they spell pi, they would spell it like, like apple pie. They would spell it like this. How many centimeters is an inch? 2.54. That's how you spell pi in Greek. Okay, so anyways, the Greek letter D is delta, and we just use it in science. We use it for the word change. It means change. Delta D means change of position or displacement. P2 refers to the second position in the formula. P1 refers to the first position. When I did my subtraction right there, I've got initial and final. Initial would be the 1, final would be the 2, and then you subtract them. 2 minus 1, right? So displacement is always second position minus subtract first position. You need to know that. That's a formula that you want to have on your cheat sheet. Okay? Okay. Here's a couple examples. I'm sure you'll find them very easy, being the smart group that you are. P1 is equal to, we have to do P2 first. P2 is equal to 5. P1 is equal to 3. Delta D is P2 minus P1. Are you guys supposed to be writing this down, maybe? Fill in the blanks at least, right? So delta D is going to be simply 5 minus 3, or plus 2, which means 2 steps to the right. Really, it can't get a whole lot simpler than that, can it? I've probably made it far more complicated than it needs to be. I'm guessing you could probably do this next one on your own. It's pretty hard, eh? P2 is equal to plus 2, it's right there. P1 is way over here at minus 3. Uh-oh. Is this going to be hard? Here's where hopefully you paid a little bit of attention in grade 8 or so when they start doing integers, positive and negative numbers. P2 is going to be minus 3. Sorry, P2 is 2. P1 is minus 3. So I subtract minus 3. I hope you realize that that's plus 5, right? Which, of course, is 5 steps to the right. Can you count? 1, 2, 3, 4, 5? Sure you can. Okay, so I was at minus 3. I am now at 2. I've had the displacement of plus 2. Who cares about this stuff? Anyone?
No.
Probably not. Well, you never know.
No.
Who might actually use something like this, but only more complicated?
Sniper.
Sniper?
They use for bullets.
They might need to know how far away something is, and then they'd have to do 2D projectile motion. They would probably just know how much it's going to drop. They might have a chart somewhere that tells them how much the chart.
Yeah, I'm pretty sure they do 3D because they also.
They'd have to account for wind. That's true. Yeah, left and right. If you're a pilot, you would need to know a little bit about this stuff when you're doing navigation. You're trying to fly from here to there and you're charting your course.
You guys put it together.
What if your GPS fails?
If it fails and everything is like.
Well, people kind of tend to want to stay alive, Christian. It's sort of human nature.
You'll let it down and if you see wind, that's where you
Then put her down, right?
Yeah.
Just put her down.
Remind me never to go flying with you. If anyone ever sees me getting in a plane and he's the pilot, chance, just say, hey, Mr. Mann, are you sure you want to do that? Would you do that for me? Thank you.
Just you jump out and something music.
Now, what about, what's different about this last one here?
It's the other way around.
Cars are going the other way, exactly. Is that going to be a problem?
Yeah, we gotta go from there to there.
Not going to be a problem. P2, this is where it ended up. The final's at -4. P1 is at +2. So I'm going to go -4, -2. -4, -2. I subtract. And I can see, you can see it poking underneath there. It's 6 steps to the left or -6. Did it go 6 steps to the left? Sure. -6, the car's going to the left, that's all. Right? Once we get done with the displacement, then we can get into velocity. I got a couple labs for you. We're going to roll some balls down ramps and do some graphs and stuff like that. Okay, we got to get sort of take care of this basic stuff first. No. Oddly enough, I won't allow that. Hard to believe. Okay, there are very few exercises there. Like there's like 6. Okay? Oh no, I'm sorry, there's more than that. It's all the way to 8, right? Go ahead and do that. Give that a whirl. It's fairly easy. I can't imagine it taking you more than about 5 or 10 minutes, and then I'll go through the answers. No, I don't. Okay, just to be sure, we got this right here. Let's just go through the answers, Kate. Right? Good? Okay, so negative position means an object is to the, sorry, positive position. I read that wrong. Positive position means the object is to the right. A negative position means that an object is to the left. The position of that car is -1. B is that +4, right? Not hard stuff at all. Positive displacement means motion to the right. Negative displacement means motion to the left. What is the displacement of following cars? Number 6 there is +3. All you do is count, really, right? It's 4 - 1 if you want to do it that way. The next one, B, is +7. It would be 4 minus -3 or +7. We're all going to get 100% on this. Why not? It's easy math. P1 and P2 are equal to P1 is -4, and P2 is equal to +1. D there, P2. Now, how do you know which one is which on these? Which way they're facing, exactly. You got to know which way they're facing. You have to actually recognize it, right? So in D, P1 would be the one at +2, and P3 would be the one at -3. Drawing a number line. Okay, I'll just do it quick here for you, right? Place a car at position. You should always put 0 on there. So +1 is P1. Does it matter which way I draw my car facing?
Yeah.
I'm just going to do that for now, because I don't know which way it's going. P2 is at +5 over here. Okay. What's the displacement? Obviously, +3. The car is going to the right. Easy stuff. Draw a number line. Draw a car at P1 is at 2. Yeah. What did I say? Oh, it is 4. Oh, man. I guess I'm not going to get 100%. Oh, jeez. +4. Well, I guess it shows that everybody can make a mistake. There's my mistake for this month. Hey? No?
Mistake for this month.
Yeah, that's what I said. Actually, I think I'm in it next month already. I think I made a mistake already this month. -4 is where we start at. Oh, no, we start at +2. +2. Okay. There's +2. That was just a boo-boo. That's not a mistake.
That's the same thing.
No, it's not. I beg to differ. -4 is over here. And the car is going left. What's the displacement? I better ask you in case I get it wrong.
What is it? Negative.
What is it? You tell me. -4. I went from +2 to -4. -6. Easy, easy, easy. Right? I never did show you this one. If I go out and run around the track, now in my younger days it would take me a little under a minute. Now that I'm a little ancient, it'd probably take me about 5 minutes. Okay? But if I start here and I go all the way around the track, and the track is a 400 meter track, it's technically 401 meters out there. Someone screwed up when they built it. Hard to believe. Someone didn't pay attention in science class, and they built a track that's 401 meters long, and it's actually technically ineligible for any proper competitions. But that's just another story. Yeah, really. It's actually 401 meters long. Yeah, actually the swimming pool downtown is, I think it's only about maybe 8 inches short, and it's ineligible for actual competitions too, because it's just a little bit short. Why wouldn't they actually measure the pool and get it right? Close enough, right? No, someone just said close enough, good enough, and now Dauphin can't host major competitions, all because someone said, it's good enough. It does kind of seem like something you would do, Christian. Yeah? I don't know, but easy. It's certainly possible, right? How would you fix the track? How would you knock off a meter off the track because it's too long? So what they actually have to do is they have to start the start line. Yes. If you'll notice, it's probably faded now, but when they originally painted the lines on the track, they actually screwed up on those as well.
Like our track?
Yeah, our track.
So it's a meter too long.
It's about a meter and a half too long.
So that we can't run a mile now because that's not.
Actually, when you run 4 lengths, you're running a mile plus 4 meters.
That's not fair, but I'm getting off by 4 meters.
So then what they could do is they could tear off half a meter off of one end. So
They'd have to move like the entire end. They'd have to like. It's pretty much impossible. No, it's certainly not worth it. Someone screwed up. Anyways, back to my original discussion here. So yes, the difference between distance and displacement. If I run the 401 meter track, that is my distance traveled, right? But if I end up at exactly the same spot that I was before, right? My distance is 400, but what's my displacement?
1.
If I end up at exactly the same spot, my displacement is a big fat 0. Because my final position minus my initial position is the same thing, 0. Good. Okay, there's a little sheet there. This one I'm going to ask you to hand in. You don't have a whole lot of time, so I'm going to be nice and I'm going to say,
Only do the first question.
you got to pick one of A or B. Your choice. Your choice of one of A or B, and then both parts in number 2. That's all I need.
Okay.
Okay, I think that's fair.